Lesson 32, matrix operations. We will be able to add and subtract matrices and multiply matrices by scalars. So an operation, if you don't remember, by the way, is what we do to numbers. We already know these are our standard operations that we use all the time, and we use it with lots of different things in maths. Now, when we start off with mathematics, the first thing I usually teach students to do is how to add numbers, how to subtract, how to multiply numbers. The next thing we usually do is then, well, let's use some different types of numbers. Let's use fractions. Then after we've talked about fractional numbers, we then talk about decimals. And then we talk about negative numbers. And so every time, being a teacher, I've had the advantage of being able to do this. Every time I go into a lesson and we're teaching a new idea, whether it's fractions, decimals, negative numbers, whenever we teach a new idea, we always go through these 4 operations. And like a couple more examples, like I teach vectors to my year 10s sometimes in engineering maths. I go through these operations. If you were in advanced maths, you may have seen complex numbers. You learn how to add, subtract, multiply, and divide complex numbers. It's just a good way to build up our language. Pardon me. Now, one second. Hey, can you not die in the middle of my meeting? Thanks. Okay. Now, lesson 32, by the way, the fact of that is the size of a full set of adult teeth is, including wisdom teeth, is 32. I've had my wisdom teeth taken out when I was 19. Some of you guys may have had your wisdom teeth taken out as well. So, but yeah, like 32 means the number of teeth. So, now, guys, 1 second. I'm gonna have to deal with a dog that's being very loud and annoying. Are you gonna stop? Okay, right. Sorry about that, ladies and gentlemen. It's one of the hassles of trying to teach from home. Okay. So, sorry. Let's go back to what we were talking about last lesson, and then we'll come back to this slide. Last time what I was talking to you guys about with matrices is just the basics. The basics of the matrix is that it has columns and rows. Now, it's also just a square, it's also a rectangular array of elements. Those elements can be, I still haven't changed it, by the way. Those elements could be letters, they could be numbers, they could be fractions, they could be decimals. It doesn't really matter what they are. They are just a collection of these ideas, these elements. The rows run left to right, the columns run up to down. We can name individual elements by looking at the ij, I being their row as you go down, and j being the columns. So when I say 2, 1, that means I'm talking about row 2, column 1. So there's 5. Right, I'm gonna have to move this dog. Sorry guys, give me a sec. Sorry guys. Sorry about that. Okay. She's got she's a little dog, so she's got this weird cough that she gets because she's got such a small airway, and it's pretty normal, but it can get very loud and very annoying. Okay, so we talked about 3 types of matrices. We talked about a row matrix that's just a left to right, it only has 1 row. We talked about a column matrix that's up to down, it just has 1 column. And we talked about a square matrix, which happens to be when the number of columns equals the number of rows. You can see with this one, I tried to experiment by using different, like, let's use a half and a negative number just to get you guys familiar with it. Doesn't have to be just, the elements can be whatever they want. We said an order of a matrix. Now I don't have a slide for this, but it's okay. The order of the matrix is the number of columns by the number of, the number of rows by the number of columns. And it's usually written down as this: a 2 by 3 or maybe a 4 by 4 matrix. Now this X in the middle doesn't mean times. You don't go 2 times 3. You just write 4x4. I don't know why they chose to do it this way, but that's just the way that it's done. It can be a bit confusing. Then we went through a practical example. We took a matrix like this and we turned it into like a matrix. We said, how many paths are there from A to A? How many paths are there from, and we made a matrix for this so that we could look at how these roads are connected to each other. How many roads from A to B? There was 1. How many roads from C to A? There was 2. How many roads from A to D? There was 0. How many roads from C to B? There was 0. How many roads from... And then we did this for every combination. And then once we've done this for every combination, you could actually, once you've done it for one side, you can then just mirror it. It's actually quite easy to do. And then, and then that becomes a matrix that you can then use to figure out how many paths there are between each individual point. We then constructed one from this map here, where we did the same thing with A, B, C, A, B, C. We made our own map. Now, I've then set you guys to work on 5A and 5B. If you haven't finished 5A and 5B by now, that's something that you really should be working on today to get that done, because ultimately we're going to be working on 5C and D today. Like, that's going to be the next topic. So yeah, speaking of 5C and D, so 5C and D is all about matrix operation. It's all about, can you add, subtract, multiply, and divide. But we're not really going to be talking about, one thing we're not going to be talking about is we're not going to be talking about a matrix multiplied by another matrix. Now, we will talk about how to add 2 matrices together, how to subtract 2 matrices, but we're not going to talk about a matrix times another matrix yet. When you multiply a matrix by another matrix, it actually is a lot harder to do. There's actually some special rules that exist to make sure that matrix multiplication behaves the same way as regular multiplication. Matrix multiplication is also very unique because it's pretty much one of the main reasons that sets it apart from other sort of number systems. So we're not going to do multiplication of 2 matrices today. What we will do though is we will do multiplication of a matrix by a scalar. That's like saying 4 times everything in a matrix. So that's what that means there. Okay, first things first. adding and subtraction. Oh, this is so annoying. All right, hold on. I'm going to talk about this in a sec. Dog's want to come back inside now. Oh, of course you guys want to come into the room that I'm teaching you. Huh? And of course you're going to bark. Oh, it's going to be annoying. Okay. Addition and subtraction is done by adding or subtracting corresponding elements. What that means is that addition and subtraction of matrices can be performed only if the matrices are the same order. Now, this is actually really important. That means that you can't add, if you have a 2 by 2, you can add it to another 2 by 2. That will work. But you can't add a 2 by 5 to a 2 by 2. That's just, you can't do that. It's not allowed. And you think about it, it sort of makes sense that you could only add other matrices together, and how you add them is actually quite simple. I'm not sure if I'm going to go through an example later on, but I'm going to go through an example here just so that I've done an example. Let's do one really quick. Let's do 1, 1, 4, -3. I'm going to add that to 2, 4, 3, 8. Now, firstly, we can check that they're the same order. This is a 2 by 2, and this is a 2 by 2. They're both the same order, they're both the same size. When we add the two matrices together, what you do is you go, well, this top left one here is going to get added to this top left one here, is going to make this top left one here. So 1 plus 2 makes 3. And then so on. 1 plus 4, that's going to make 1 plus 4, that's going to make 5. Then we've got 4 plus 3, that's going to make 7. And last but not least, -3 plus 8 is going to be 5. And so all we're doing is we're adding each individual element to each individual element to each individual element in the other matrix. And it doesn't matter if they're negative or positive, that's just going to mean the same thing. So, and subtraction is done by the opposite way, of course, is just by subtracting those numbers. And so you would go 1 take away 2. If you were subtracting, then this would be 1 take away 2, which would be -1. 1 take away 4, which would be -5. 4 take away 3, which would be 1. And then -3 take away 8, which would be -13. But that would be if we were subtracting. But we're not actually subtracting here, we're just adding. But it's the same process is what I'm trying to say. All you're really doing is you're multiplying one's whole matrix by -1, and then you're adding it. So let's talk about now, what are some other properties? Sorry guys, I stole this from addition of matrices is commutative. That means that the two matrices A plus B and B plus A are the same thing. Whoa, sorry. So that's pretty useful to know. Just because it comes up later on, this is going to come up to be important. So commutative property just means that if I have a matrix, let's just do a matrix here really quickly, 1, 2, and we'll add it to 6, 8. It doesn't matter if I do 1, 2 plus 6, 8, or if I do 6, 8 plus 1, 2. They will both result in the matrix 710. Doesn't matter which order I do it in. The reason that's going to become important is because later on we're going to talk about there are situations where the order of things is important. So, but we're going to come up to that when we get up to it. So, first up, let's look at some examples. I did say there turns out there were examples that we could have done. So let's look at this. First question that I'm going to ask is, first thing I'm going to give, you know what? I'd like you guys to give these a try. I would like you guys to work on these on your own for a second. Okay? So I would like you guys to see if you can figure out this first one, see if you can figure out the second one, and see if you can figure out this third one. I'm going to give you guys 2 minutes to do that, and then we're going to go through the answers together to see how we went. Okay? So give them a try. Maybe, yeah, about 2 minutes, because it shouldn't take you too long to do. I'm gonna. By the way, while you're trying to work these out, let me see. Jimmy, make sure you do the attendance questions. That's why you come in late. All right, let's go through the first one. A plus B. I'll do the first one properly. The other ones we're going to go through quickly. A bit faster. Okay, so the first one, A plus B. So we've got 1, 2, 3, 4. Then we're adding that to 1, 4, 2, 3. First thing we need to do, are these the same order? This is a 2 by 2, this is a 2 by 2. Yes, we can add them. That means that we add the top left, which becomes 2. We add the top right, which becomes 6. We add the bottom left, which becomes 5. We add the bottom right, which becomes 7. 2, 6, 5, 7. With the second one, B, I'm going to skip a step here because I'm just going to write down the answer. B is A minus, this second one is A minus B. So I go 1 minus 1, that's going to be 0. I'm not even going to write it down because I just want to do this quickly. 2 minus 4 is going to be negative 2. 3 minus 2 is going to be 1. 4 minus 3 is going to be 1. So 0, negative 2, 1, 1. Now B minus C. So the problem with B minus C though is C is a 2 by 3 matrix. And B is a 2 by 2 matrix. So that means you can't actually multiply it. You can't actually subtract it. Can't be subtracted. And the reason why, wrong order. So they're not the same order. This is a 2 by 2, this is a 2 by 3. If this had an extra column here, then we could do something, but we can't. So that's just the quick and basic stuff here. This is how you add and subtract them. So that's pretty much like 2/3 of the lesson that I wanted to talk about. The last little third is going to be about multiplication by scalar, But before we get that, I want to show you a brand new type of matrix. This new type of matrix goes along with the matrix types that we've talked about. So the row, column, and square. This one though is different because it has special elements in it. It's called a zero matrix. In a zero matrix, every element is zero. And the reason why a zero matrix is useful is because adding or subtracting a zero matrix does not make any changes to the original matrix. So if I have this zero matrix, and I could also have a zero matrix that looks like this, or a zero matrix that looks like this. So if I had let's just take if I had this, right? 1, 4, 7. And I added it to the zero matrix, 0, 0, 0. Well, 1 plus 0 is 1, 4 plus 0 is 4, 7 plus 0 is 7. Even though I've added a matrix to it, I've actually haven't changed that matrix. Now that might seem obvious to you. Might seem like, well, that's clear, that's fine, that makes sense. The reason why we're teaching you this is because when we talk about 0 in like regular numbers, like 3 plus 0 is still 3. We want to make sure that we've got a way that we know what is this number, what is 0 in matrix form. Later on, we're going to talk about what this is. If I go 3 times 1 equals 3, and I'll say later on, I'll talk about tomorrow. What does this 1 represent? What's so special about this 1 here that makes it so that the starting number and the ending number is the same? We're going to talk about what that 1 is and what that means for matrices next lesson. But at the moment, a zero matrix is just any matrix. It can be any size. I should be very clear on that. Any size you want. And it can be square, rectangular, whatever. It just has to all be made up of zeros. Last but not least, I'm going to talk to you guys about is multiplying by a scalar or scale factor. When multiplying a matrix by a scalar, each element is multiplied by that scalar. We're going to do an example. We're going to do a pretty difficult example. We're going to find what happens if you take 2a plus 5b. Now to do that, we're going to do that because this is a bit involved. We're going to do it in 2 steps. So how I'm going to do that is, well, 3 steps actually, to be honest with you. We're going to do over here. I'm going to do this. 2a equals 2 times -1, 3, 4, -4, which is going to equal, so now when multiplying a matrix, each element is multiplied. So 2 times -1 is -2. 2 times 3 is 6. 2 times 4 is 8. 2 times -4 is -8. That is now 2a. So everything gets multiplied by this scalar at the front. Let's do the same thing now down here for 5b. So 5b is going to be the same as 5 times the matrix 3, 0, 0.2, 0.5. 5 times 3 is 15. 5 times 0, still 0. 5 times 0.2 is 1, and 5 times 0.5 is 2.5. If you are not as quick to work out, if you're not as quick to dealing with decimals as I am, and you want to use a calculator, that's fine, but you should be probably at this point in time pretty quick at dealing with them. So now, 2a plus 5b is the same as saying 2 times -1, 3, 4, -4 plus 5 times 3, 0, 0.2, 0.5. Now we've already done that, so we've actually got, it's actually equal to -2, 6, 8, -8. And the other one is plus 15, 0, 1, 25. 2.5. Well, that was close. Now, we can add these together because they are the same order. This is a 2 by, the one on the left. It's always good to check it. This is a 2 by 2. And this is a 2 by 2. So multiplying by scale, it does not change the size of your matrix. So now, dealing with all of this together, -2. -2 plus 15 is going to make 13. 6 plus 0 is going to make 6. 8 plus 1 is going to make 9. -8 plus 2.5. Remember, it's not 25, like I almost made a mistake here. That's going to be -5.5, unless I'm wrong, which I have been in the past, but that's how you would solve that problem. So that's, and I did that in 2 parts to show you guys how you would do it. If you wanted to do this all in one section, if you wanted to just use this section in the green, I actually don't mind that. That's fine. I just thought that I would show you that so that you guys sort of could see how you would do it. What I'd like you guys to do now is I'd like you guys to now work on 5A to D, specifically because I assume most people have already done 5A and B. What I'd like you to work on now is 5C and 5D. Let's go have a quick look at them before I dismiss you guys to work on those.